this thing works is you have two problems of the same concept. So I'll do like the odds and you guys do the evens. All right, number 3, draw a function that has a domain negative infinity to infinity and the range of -2 and infinity. Since we've been doing a lot of absolute value functions, there's -2 on my y-axis, right? Very easy. Just draw an absolute value function at -2 going to positive infinity. Okay, number 5. Describe the transformations of the absolute value functions. Accurately graph an absolute value function. And create an absolute value equation given a graph. So that was 2.7. Let's see, number 5. Which way do I go inside the absolute values? Right 3. How about outside? Good. Oh. What about the number in front being multiplied to the absolute value? That's right. Vertical stretch of 1/2 or 0.5. Inside the absolute value is the opposite of the sign, left 8. And then the last one, -5, down 5. You guys should get 100% on this quiz tomorrow, right? It's the slope, the number before the absolute value. Vertical stretch of 1/2. What does a minus sign do? Reflects over the x-axis. Anything else that's kind of okay? Number 9. This is off of the formula, the general equation of absolute value, y equals a times the absolute value x minus h plus k. Everybody remember that, right? Oh, by the way, I put that note sheet on Google Classroom. You guys can print that out and use it on the quiz tomorrow. I'll try to print some off, but chances are I'll be old and feeble and will forget. It's got this formula on there, and it tells you what exactly the transformations are. The vertex is h comma k. So my vertex for number 9 is 2, but I have to make it. I have to get that sign to change, so I'm going to say -2. Same with the k. I need to change the sign as well, so it's going to be a -7. So there's my vertex, -2, -7, -2, -7. Because it's got a +2 in here, and I need to make that a minus. Okay, so I'm going to stick a minus sign with the 2. Okay, same with the thing with the k. The general formula has a plus sign here, but there's a minus sign here, so I'm going to stick one there because a minus makes a positive. Okay. We're going to have to use our calculator to graph this. Okay, because we got a vertical stretch and everything. You could do it in, oh, somebody else is missing. Key. Let's see, 3. Let me clear this. 3, hit the math key. Absolute values under num, and then hit 1. X plus 2. Well, because I need at least a couple of good points. Yeah, you could, but I'm not that good, so I'm going to use a calculator. -7. Oh, I forgot I got my 3 there. So graph it. And then I'm going to go to my table, hit my second. God, look how dry my fingers are. You see the dead skin there? Look at that. It's crusty and flaky. I need some lotion. Let's see. My vertex is -2, 7. So a couple of good points there. -3, -4. What? Yeah. Let me write down my points. -3, -4. Let's see, 1, -4. Okay, here's how I did it in my calculator. Go to your y equals. Okay, I put in this equation 3. Now the absolute value is, hit the math key and highlight, use your arrow key to go to NUM, numerical. And then the first one is ABS, absolute value. Just hit enter. Okay. And now I put in what's in my absolute value, X plus 2. Close the parenthesis. You have to close the parenthesis. And then -7. Okay. And then, are you with me? You got. So I got -3, 4, -3, -4. See how you get that slope, Jacob? Up 1, 2, 3 over 1. You can do it that way. Up 2 over 1. Or you can put it in your calculator. I think it's easier for me, but not all students, okay? 1, 2, 3 over 1. 1, 2, 3 over 1. Most students elect to use a calculator. Okay. What? My other gel pen is gone. No, we've been out of red gel pens in the math department for quite a while. I think they're ordered. They just take a while to get in. I could go to the store and buy one, but A, I'm too broke. B, I'm too lazy. And I'm not sure which order those are going to be in. All right. Questions? Any other questions? All right, then we have to write an equation. You guys did really well with this. You have to write an equation with of an absolute value function. Okay. My vertex is -2, -5. How? I know. Sorry. Let's see. I'm plugging it into the f of x equals a times the absolute value x minus h plus k. I have my h and I have my k. I need my slope. So my slope is up 1, 2, 3, 4, 5, 6, and over 2. So my slope is 3. I think I got everything right. So my equation is the f of x equals my slope, which is 3, x minus, let's see, negative 2. So it's going to change it to a plus 2. And I've got a plus negative 5, which is going to change it to minus 5. So that's the first one. You guys can do the other two. Now, piecewise functions. This is where you guys took a train wreck. Okay, evaluating piecewise functions. Now, remember, function notation is just the 5 is what equals x. Okay? So you look at 5 and you go, well, is 5 less than or equal to 0? No, it is not. Is 5 greater than 0? Yes, it is. So you have to use this function. Negative 5x plus 1. So you stick in what x is equal. Negative 5 times 5 plus 1, which equals negative 25 plus 1, negative 24. How about negative 1/2? Negative 1/2 is less than or equal to 0. Yes, it is. So we have to use the top function, which is 5x minus 3. So 5 times negative 1/2 minus 3. And oh my gosh, we have fractions. I'm just going to skip it. What's negative 5/2 minus 3? Negative 5/2 minus 3. Well, what's 3 in half fractions? Negative 5/2, because I'm just multiplying the numerators. 3 is 6/2, right? Sorry. So negative 5 minus 6, negative 11 halves. That's my answer. Negative 5 minus 6. What? What, the green? Purple. It looks like it's the contrast that's messed up. Yeah, did you get makeup in your eyes? Yeah. Ooh, let's try brightness. Oh, whoa. No, we can't use same color pen. That would be against my morals. That would be against my morals and ethics. All right, the f of 0. 0 equals 0, so I have to use the top one. So 5 times 0 minus 3 plus negative 3. This one? Okay, negative 1/2. Negative 1/2 is less than 0. So I have to use the top functions. So I have 5 plug in negative 1/2 for my x minus 3. 5 times negative 1/2 is negative 5/2. Okay? 3 Uh-oh. My thing's out of shape. Never fear. We have extra whiteout. We don't have red pens, but we have extra whiteout. Okay, I'm going to change 3 to halves so that I can combine these two fractions. 3 is 6/2. 6 divided by 2 is 3. Okay, so negative 5 minus 6 is negative 11, and I keep the denominator. That's how I got negative 11/2. Okay. All right. Here we go. Here's the train wreck. Yep. Okay, number 13. Here's my boundary line. So at negative 3, I have a boundary line. Here's my boundary line. X equals negative 3. Okay, the top one. The restriction to my domain is x is less than or equal to negative 3. I have to use the function 2x plus 7. Okay, that's less than negative 3. Anything greater than negative 3, I have to use the function negative 1/3 x minus 5. Now, I need at least 2 points to make a line. And the first point, I have to use x equals negative 3. For this one, for the one greater than negative 3, I have to pick a point greater than negative 3, so I'll use 0. That's greater than negative 3. Okay, let's plug in negative 1/3, and my x is negative 3 minus 5. Negative 1/3 times negative 3 is positive 3/3, which is 1. 1 minus 5, negative 4. Okay, now I chose 0 for my next point. So I have negative 1/3 times 0 minus 5. 0 minus 5 is just negative 5. Okay, this has the equal sign, so this is a closed circle. So negative 3, negative 4, it's a closed circle. 0, negative 5, 0, negative 5 is another point. So here's my line for that restriction. Now I got to do the other one. X, Y. I need 2 points. It's an open circle. Yes. I have to use the negative 3 for my first one. Second one, less than -3. I'm going to choose -6. Okay, 2, actually -6 is going to be too big. Let's try -4. 2 times -3 plus 7. -6 plus 7 is 1. 2 times -4 plus 7. -8 plus 7 is -1. Okay, so I have -3, 1, -3, 1, open circle, -4, 1, -1. So here's my other line. Yeah, you guys had a little bit of tough time with this, so you need to practice, practice, practice. Okay, then we did radical functions. The transformations are pretty much the same, except instead of absolute value bars, we have radical. This is a square root. So the transformations, vertical stretch of 2. We're going to go right 3. And we're going to go down 4. I would highly suggest putting this into your calculators because I think there's only one person that can remember the points of the parent function. Keaton. So I got 2 square root of x minus 3, close parenthesis, minus 4. Graph it. And I should get a curve. I'm going to go to my table, and it starts at 3, -4. So I'm going to list some good points here. 3, -4. 4, -2. 7, 0. Let's see, 3, -4. 4, -2. And 7, 0. So here's my curve. The what? Okay, my domain. Let's see, the smallest number is going to be 3, includes the number 3, and it's going out to positive infinity. The range, the smallest number is -4, including -4, and it's going up, up, up forever to positive infinity. Oh, hit second graph. And let's do a cube root. Let's do 17. Transformations. Reflect over the x-axis. Vertical stretch 4. And right 2. Okay, let's put the cube root in our graphing calculator. Cube root, hit the math key, and number 4 brings up the cube root. Oh, I forgot to put in negative 4. And I've got x minus 2. Graph it.
So what did I miss?
Quiz review for the quiz tomorrow.
Oh, dang.
Pick up some points. Ooh. Oh, yeah.
Hey, Riley. So, can you add the, how to do the calculator stuff to the notes?
I will, yeah, if I remember.
Thank you. I'll be back in later.